Okay, let's continue on the chapter 1 about streamline and linear equations. Let's talk about linear equations, and then we're going to get into the slope and the y-intercept, or different kind of important elements in the linear equation. Okay, so let's look into that. First of all, on section 1.3, we're going to look into the linear equations with straight lines. And we're going to take a look at the different form of the linear equations. We have a slope-intercept form, which is y equals mx plus b. And we also have a point slope form, y minus y1 equals slope times x minus x1. And those two are popular ones, and we're going to go into the details about how to use each one of these to understand the nature of the linear equation and the straight line. And in finance or accounting, they use this term called depreciation. So depreciation is a term utilized to depreciate assets, right? So they depreciate assets over the life of the asset terms. For example, like buildings, machines, furniture, vehicles, equipment. So they depreciate that, meaning the value goes down over the time. Value goes down over time, and they do that for income tax purposes because depreciation could be utilized to decrease the income tax. So they use this method called linear depreciation, meaning they use straight line method to depreciate the asset. For example, if you look at the next slide, following graph shows the straight line depreciation. So we have a network server here, and the book value of the network server that has the initial value of $10,000, and it's being depreciated linearly, meaning using straight line depreciation. For 5 years with the scrap value. Scrap value is also called residual value. You can also say that remaining value, scrap value, $1,000. So at a time t equals 0, so the value of the machine is worth $10,000, meaning when the company first purchased the network server, it's worth $10,000. So all the pair we use to describe this would be 0 time t. So the horizontal axis represents time t, right? And vertical axis represents dollar value, $10,000. And also the second condition is after 5 years, when t equal to 5, then the value of the machine of t equal to $3,000. T equals 0, and value of the machine is $10,000, which is initial purchase price. After 5 years, the value of the machine goes down to $3,000. And that basically determines the relationship between the time t and then the value of the machine. And this is one of the important application of the straight line or linear equation. And we're gonna get into details later on, right? How the calculation get the equation of the straight line in a second. So first of all, we're gonna take a look at slope of the line. Slope m measures thickness of the line, meaning captures the stiffness of the line. And L, so right here we have a line L here, denotes a unique straight line that passes through 2 points x1, y1. So point 1 is x1, y1. Point 2 is x2, y2. So the slope is represented as a vertical change. So this is vertical change of a horizontal change. Horizontal change is here. And in the mathematical symbol, we do vertical change. We use delta y for vertical change. Horizontal change is delta x. So delta y over delta x. So slope equals delta y over delta x. Delta y is changing y values. So y2 has bigger value minus y1. And here this is y1. That means this is y1. So y2 minus y1 gives us delta y. Because this one is y2. Y2 minus y1, that's delta y. Similarly, if x2 minus x1, that gives us delta x. So slope is captured using this formula. So keep that in mind. Every time we try to find the slope, we use this slope formula. Okay. And if x1 equal to x2, that means that the line is vertical line because there's no horizontal change. So if you're using the slope formula, delta y over delta x, y2 minus y1, x2 minus x. Here, since x1 equal to x2, given x1 equal to x2, and the denominator becomes 0, so we get y2 minus y1 over 0. Any number of 0 that's undefined. That means the vertical line has no slope. The vertical line has undefined slope. Vertical line has no slope. What's very special about vertical line, all the vertical lines, including the y-axis. Y-axis is vertical line. We use x equals 0 to represent the y-axis. And then this line doesn't have slope either. All right, so delta y is y2 minus y1, and we use delta to represent the change in y values. Delta x is x2 minus x1, so we use delta x to represent the change in x values. So right here, this part is delta y, y1, this part is delta x. So delta y, so slope m of any straight line L is a measure of the rate of change of the y with respect to the rate of change of x. So slope equals to y delta x, y2 minus y1 over x2 minus x1. And this is graphical aspect of the slope. And the slope of any non-vertical straight line is constant. So constant is what we call the slope, right? So this constant refers to the slope. So the rate of change is constant, meaning in this line, for example, like line L1 here, since the vertical change is 2 units, so going from this point to this point, move to the right 1 unit and move up 2 units, right? Move to the right 1 unit and move up 2 units. And move up 2 units indicating its vertical shift, so delta y equals to here delta y2, here delta x equals to move to the right indicates other 1. So slope equals to delta y over delta x. That's 2 over 1, that's 2 units. So here the slope is 2, positive, and positive slope indicates the line is increasing. Okay, so this is increasing now. Meaning going from left to right, it's going upward, right? The line rises. So the slope is greater than 0, then we have this conclusion is increasing line. So going from left to right, the line is going upward. We also have a decreasing line. Let's say the slope is negative and less than 0, that means we're dealing with a decreasing line. And this tells us from left to right line force. Okay, so going from left to right, it's going downward. And right here, from this point to this point, we get a move to the right. 1 unit. That tells us delta x equal to 1. And then you're going to move down 1 unit. Move to the right 1 unit, move down 1 unit. Move down 1 unit. To get to the second point, point B. Point from point A to point B. We do that. So this here, delta y equals -1. Going down, it's negative. Going up is positive. Move to the right, positive. Move to the left, is negative. All right. Left or right. On the right, positive. Left is negative. Okay. Up and down. Going up, positive. Going down, negative. So slope equals to delta y over delta x. So it's -1 over 1. And -1 indicates it's a decreasing line, right? Because slope is less than 0. Okay, so observing the different lines with different slope, and we can come up with some kind of a pattern. So if you look at this family of the straight line passing through the origin right here, right? So you have slope equal to half, slope equal to 1, slope equal to 2. Compare all three of them. As the m, when the m increases, the slope increases, then the line becomes steeper. So slope is measures steepness of the line, right? So as the line, the slope increases, this relationship. On the negative side, it's kind of similar. So -half, -1, and -2. The absolute value of these all negative numbers, again, 2 is bigger than 1, 1 is bigger than half. So as the slope of the line gets smaller on the negative side, then the line becomes steeper. So that's on the positive side. And the negative side. So distinguish them, but again, if you look at the absolute value of the slope, right? And when the absolute value of the slope increases, then the line becomes steeper. Now let's take a look at this. Sketch the straight line that passed through the point -2, 5, the slope -4 over 3. So we are given the point, we're given a slope. And then we try to plot it. So first of all, you're going to plot the given point, 5. X value is going to be 2. Y value is going to 5. 1, 2, 4, 5. So we have the point right here. And from that point, we have a slope, which is -4 over 3. So -4, that's a vertical shift, meaning this line will go down 4 units. And +3 on the bottom indicates it will go to the right units. So go down 4 units. So from 5, you don't follow down 1, 2, 3, 4, go here, and go to the right 1 unit, 1, 2, stop here. So we get a second point right here, and the second point turned out to be 1, 1. Okay. So even point -2, 5. utilizing the slope, we've got another point. Connecting those 2 points, get a line. All right, so this is a line passing through -2, 5, and it has slope of -4/3. So we are utilizing the slope here to locate another point on the line, and we know that 2 points can make a line. And that's how we determine another point and then get a line. All right, so now the next thing is find the slope m. Then true find slope m of the line that passed through the points -1 and 1, 5 and 3. So we are given 2 order pairs. Now to find the slope, we label the first order pair x1, y1, second order pair x2, y2. So the slope is equal to y2 minus y1 over x2 minus x1. We call this the slope formula. Use a slope formula, replace given variables with the number. So y2 is 3, y1 is 1, x2 is 5, x1 is -1. We end up with the 2/6. Right? On the bottom is 5 minus -1 becomes 5 plus 1, 6, 2/6, that's 1/3. Simplify that and get 1/3. So slope is 1/3. This is positive. That means it's increasing line. Okay. Now we can quickly confirm this, right? That's plotting -1, 1, right? And then plotting 5, 3. Connect, then you get a line from left to right increasing. Going from -1, 1 to 5, 3, you gotta go to the right 6 units. From -1 to 5, that's 6 units here. So it means delta x equals 6. And then from this is 1 to 3, delta y equal to 2 units. If we do slope equal to delta y over delta x, 2/6, that's 1/3. And we confirmed our calculation from the previous slide when we add those 2 points and then generate the slope from those 2 points. We graphically we also get that. All right, so now let's take a look at slope of the line. Look at some special lines like horizontal line. So the x-axis is the horizontal line. So for the x-axis, the equation for x-axis y equals 0. As you can see, there's no slope here, so slope equals 0. So for all these horizontal lines, L1, L2, they all have slope equal to 0. All of this horizontal line has slope 0. So slope defines the line. So we can use the slope of a straight line to determine whether the line is parallel to another line. If 2 lines are parallel, distinct lines are parallel, if only if their slope are equal to each other, right? Their slope are defined, so meaning m1 equal to m2. You have the same slope, then you have 2 lines are parallel. Okay. And let L be the line number 1 that passes through -9 and 1, 3. L2, line number 2 be the line passes through the points -4, 10. So determine whether they are parallel. We determine the slope. So given 2 order pairs. So we label this x1, y1, x1. So the key thing is to find out the slope. What is slope? x1 over x3 minus. So we're going to have 3 minus 9 over 1 minus 8. 3 minus 9, that's -6. on the bottom, 1 minus negative 2 is 1 plus 2. So divide everything into the slope for line number 1 is negative 2. Slope for line number 2 negative 10. So we also label this x1, x2. So let's calculate the slope for line number 2. Similarly, it's y2 minus y1 over x2 minus x1. It's negative 4 minus x10 over 3 minus negative 4. Negative 4 minus 10 is negative 14. Keep the negative sign, adding 4 and 10, the negative 14. 3 minus negative 4 is 3 plus 4 is 7. Divide into that again. As you can see, when M1 equal M2, that indicates L1 and L2 are parallel. So that's how you determine two parallel lines. Okay. And if you plot those two points for each line, you're going to see that they form a parallel lines, right? Parallel lines. Because they have the same slope. Now let's look into the equation of the lines. So as I mentioned, we have point slope form and then slope intercept form. Get into each one of these. So now if you look at this particular line, possible A, 0, and A, comma 1. So if you look at y-axis, we know that the equation is x equals 0. This line is parallel to that should have the same form. Should have something like x equal to the x value here is A. Right? So x equal to A. So these two equations have a similar form, but different numbers, right? One of them is 0, the other one's A. So these two lines are parallel to each other. And similarly, x equal negative 2, this is line. X equal 3, this is line. Y-axis, x equals 0. So all these parallel lines have this same slope. And here the slope are undefined, right? Yes. Slope or vertical line. Undefined slope. But they are still the same. Okay. Because they're parallel to each other. Alright, so now let's look at the point slope form of the equation of a line. So let's say an equation of a line, slope m, and pass through this point, and the equation will be written as y minus y1 equals slope times x minus y2. So given slope, given the point, we can nail down the equation of the line. And for example, let's say we have equation passing through this point 1. We know that this is x1. The slope is 2, so m equal to 2. So applying the point slope formula, point slope formula, it's y minus y1 equal to slope times x minus x2. Here we know x1 and y1, we know slope. So y minus 3 slope 2 times x minus 1. On the right hand side, we distribute it using some algebra. So y minus 3 2x is 2. There we are in 3 from both sides of the equation. Cancel that, we get the equation of y equal 2x. 3 minus 2 is 1. So we determine the equation of the line. Right? Equation of the line is this. The point slope form. Using the point slope form, get this. Now, when you graph it, it looks like this. Slope is 2, right? So going from this point to this point. The right 1 unit and graph 2 units. So delta y is 2. Delta x is 1. So slope here is 2. And it matches with our slope is a number in front of x. Slope is 2, right? Matches. Now, we already talked about the parallel lines. Another special case is perpendicular lines. So if two lines L1 and L2 they are perpendicular to each other, then slope for line number 1 is equal to negative reciprocal of the slope on line number 2. Also, you can write it as product of those two slopes is equal to -1, right? So either one you like. If you know the slope for one of the line, you know the slope for the other line when they are perpendicular to each other. You can also use this symbol to represent two lines perpendicular to each other on 90-degree angles. That indicates that they are two perpendicular lines. Alright, so now find the equation of the line that passes through the point 1 is perpendicular to this line. So that means from this line we need to find out the slope. So in order to find the slope, we need to get it into the slope intercept. So write down this, and then get y by itself. Get y from both sides. Then get y by itself. Get 2x plus 1. I'll switch the order. Get y equal to 2x plus 1. So in this form, we know that slope here equal to 2. We can label that slope for line number 1. And since these two lines are perpendicular to each other, m1 times m2 equal to 1. Right? The product of two slopes equal to -1. And you can say m2 is equal to negative reciprocal of m1. So that will be -1 over 2. So slope on line number 2 is -half. Now we know -half and we know passing through 3, 1. So this is x1, y1. And we can find the equation of line. So y minus y1 slope. So y minus 1 equal to -half. That's x minus 3. And this is in the point slope form, right? You want to move further, turn it into a slope intersection, do that. But let's leave it like that for now. Point slope form. And if you draw it, you will see that on a 90-degree angle here, when the two lines are perpendicular to each other. Okay, so straight line L, when it's neither horizontal nor vertical, then it's bound to have a xy intercept. So y equals 0, this is x intercept. When x equals 0, that's y intercept. So y intercept, x intercept. And given the slope and then the y intercept of the line, we can do this. Y intercept is 0, b. Slope is given, and put into point slope form, we get y minus b. This is x1, y1. y1 equal to b, y minus b equals slope times x minus x1. So to simplify, you end up with the mx plus b. And that's how we go from the point slope form. So it's going from the point slope form to the slope intercept form. This is slope intercept form. Given the slope and the y intercept. Slope n, y intercept 0, b. So slope n, y intercept. And you can get slope intercept form, another form of the equation of the line. For example, determine the slope and the y intercept of the line whose equation is 3x minus 4y. So in order to get the slope and the y intercept, we need to del y by itself. So first of all, we isolate negative 4y by subtracting 3x from both sides of the equation. Cancel 3x with negative 4y minus 3x plus 8. By default, it's plus 8. And divide every single term by negative 4. Negative 4 gets cancelled, y is by itself. Negative 3 over negative 4 is 3/4 of x. Plus minus is minus, a by 4 is 2. So from there, we know that slope equal to 3/4. Y-intercept b equal to 2. And yeah, so by isolating the y, we get to the slope using some algebra. So let's look at real application forecasting sales of sporting goods. So sales manager of a local sporting goods store party sales units of $10,000 versus time for last 5 years. Find a point to lie approximately along a straight line. So on this line right here, we see points on the line, right? This point, for this point, time t equal to 1, then the sale is $20,000. Okay, right? Time t equal to 5, and then the sales is 60,000. And based on this, we actually could come up with the equation of the line, right? So first of all, we'll find the slope, label this x1, y1. This is x2, y2. The slope is y2 minus y1 over x2 x1. So that's 60 minus 20 over 5 minus 1. So this is 40 over 4. In case we get slope equal to 10. Meaning as a year goes by, the sales increase by $10,000. 10 indicates 10 units. 10 units is $10,000. Okay. So right here, we get a slope, and then we're using point slope formula, y minus y1, slope times x minus x1. So now slope equal to 10, x1 is 1, y1 is 20. So y minus 20 equal to slope 10 times x minus 1. Distributing by like terms, y minus 20 equal 10x is 10. Adding 20, we get the equation of the line, which is y equal to 10x. And if they want to predict when time t equals 6, meaning at year 6, what will be the expected sales? So when time t equals 6, meaning when x equals 6. So go in the equation, replace x with 6. So y value equal to 10 times 6 and 10, which is 70. Meaning $70,000. Okay. So based on the points corresponding first to the years, the equation of the trend line, we find that the sales figure will be 50%, it will be 70 units at year 6. And now, basically that we just utilize what's given in the from the graph, and then we come up with the equation of the line. From there, we estimate the sales for the future. So this using this regression model or straight line model to make prediction about the future, which is very convenient, right? So making prediction, generate the model, and use it in prediction. Because slope here indicates constant constant change. So meaning over 1 year period of time, the sales go up by 10%. So that's what this tells us. And just quickly cap what we talk about in this section 1.3. We talk about the vertical lines. All the vertical lines has the same form, x equal to a. Horizontal lines has the same form, y equal to b. We talk about point slope form, intercept, slope intercept form, general form. We haven't talked about too much, so we barely use that. Those two are more popular forms throughout the entire chapter. And in different topics, use the point slope form and slope intercept form. That's pretty much for this one, for this section 1.3.